Good morning and welcome to the online classes of Sacred Heart High School. We are going to study Geography subject, lesson number 4, Air Pressure, part 2. In the previous lecture, we have studied about altitude of the region and air pressure along with air temperature. In this lecture, we are going to learn more about it. So let us begin with our explanation. Kindly open page number 17 of your geography textbook. We will be learning about temperature zones and pressure belts. Temperature zones and pressure belts are interrelated to each other, but the latitudinal extent of the temperature zones is much larger while pressure belts are narrower. See figure 4.2a and 4.2b. For example, pressure zone extends from 23 degree 30 Celsius to 66 degree 30 Celsius. Compared to this, the air pressure belt has limited extent. It is generally up to 10 degree parallel. Children, look at the figures 2.a and 2.b. Here it is said that the temperature zones and pressure belts are interrelated, means they are related to each other. But as you can see in the figure 4.2a that the latitudinal extent of temperature zones is much larger and it extends from 23 degrees Celsius to 66 degree 30 Celsius, while the air pressure belt has a limited extent generally up to 10 degree parallel. So this means that the temperature zones are larger than the pressure belts, while the pressure belts are narrower. So children, the uneven distribution of temperature influences the distribution of air pressure too. This leads to the formation of low and high pressure belts horizontally between the equator and the poles. See figure 4.2b, page number 17. Children, as the temperature is uneven or different in all the regions, it influences or leads to the distribution of air pressure, and as the temperature differs and is uneven, it leads to the formation of low and high pressure belts in a horizontal or sleeping line manner between the equator and the north and south pole. See the figure 4.2b carefully and we get to see that between the latitudes 5 degree north and 5 degree south, the equatorial low pressure belt is formed. Between 25 and 35 north and south pole, we have the mid-latitudinal high pressure belt formed. Between 55 degree and 65 degree, we have the subpolar low pressure belt formed. And between 80 degree to 90 degree north and south, we have polar high pressure belt formed. Moving on to the pressure belts on the Earth's surface. The heat received from the sun is uneven in different regions. Hence, the distribution of the temperature is uneven from the equator to the poles. As a result, the temperature zones are created. We have studied this in the previous class. Children, as you have learned in your previous class that the heat received from the sun is uneven and not the same in all the parts of the Earth's surface, which means that the different regions receive different amount of heat, and due to this the distribution of temperature is also uneven or different from the equator to the poles, that is north and south poles. And as the temperature is uneven, the temperature zones are created. Next, we are going to learn about different pressure belts. Equatorial low pressure belt. The sun rays can be perpendicular between the Tropic of Cancer and the Tropic of Capricorn. So, the temperature is higher in this region. Hence, the air in this region gets heated, expands, and becomes lighter and moves towards the sky. As this process operates continuously, a low pressure belt gets formed in the central part of this region between the parallels 5° north and 5° south. Children, the Tropic of Cancer and the Tropic of Capricorn are in the regions that lie in the equator of the earth, and hence the sun rays are perpendicular and fall directly on them. As the sun rays are very hot, the air in this region gets heated, expands, becomes lighter, and moves towards the sun. Children, as we have seen the example of lantern, that a lantern will not move upwards to sky on its own, but as soon as we light the candle, heat comes from it, due to which the air starts getting heated and it expands, becomes lighter, and when it becomes lighter, it starts moving upwards automatically, lifting the lantern towards the sky. Similarly, here, since the temperature is high because of the hot sun rays, the air starts moving from the equatorial regions towards the sky, and as this process goes on continuously, a low pressure belt gets formed in the central part of this region between the parallels of 5° north and 5° south. This is how the low pressure belt is formed in the equator of the earth. Next is mid-latitudinal high pressure belts. The heated air becomes lighter, starts ascending, and after reaching higher altitudes moves towards the polar regions, that is, towards the north and south pole. Due to low temperatures at the higher altitudes, the air cools down and becomes heavier. This heavier air descends down in both the hemispheres in the region between 25° to 30° parallels. This leads to the formation of high pressure belts in these parallels of latitudes in both the hemispheres. This air is dry, hence the region does not get rainfall. Consequently, most of the hot deserts on the earth are found in these regions. See figure 4.2b. Children, as we learnt that from the equatorial regions, the air moves upward as it is heated and it moves towards the polar regions. Now, the equator is in between the surface of the earth and where the air starts moving to the higher altitudes. It moves in both the direction, that is North Pole and the South Pole. Now, the air in the equator got heated because of the high temperature. But here in the polar region, the temperature is low, and due to this, the air cools down again and becomes heavier. Children, before we have seen that when the air is heavier, it is near the surface of the earth. So, same ways, the air in the polar region has now cooled and has become heavier again, and hence it descends or comes down again from both the hemispheres in the region between 25° to 30° parallels, and this leads to the formation of high pressure belts in this parallel of latitudes in both north and south hemispheres. Children, mostly hot deserts are found in these regions and the air is very dry and this region does not get rainfall. Further, the next one is polar low pressure belts. Due to the Earth's curvature, the area between two parallels get reduced as we move towards the poles. This results in lesser friction of the air with the Earth's surface. Air in this region is thrown out because of this reduced friction and also because of the Earth's rotational movement. This leads to the development of a low pressure belt. This condition is observed in the area between 55° and 65° parallels in both the hemispheres. So children, the next pressure belt is the subpolar low pressure belt. Now the word curvature means curve, and as you must be knowing that the earth is curved, and due to this the area between two parallels is reduced as we move towards north and south pole. Children, see the figure. The area from the equatorial parallel belt to mid latitudinal parallel belt is more, but as our earth is curved, the area from the mid latitudinal high pressure belt to subpolar low pressure belt reduces or decreases in both the poles, and as a result the friction of the air with the earth's surface becomes less. The word friction means that two objects or two things rub against each other. So here friction means that when the air is touching the surface of the earth, friction gets created. But here it is told that the area is less, and so the friction is also lesser. And due to this reduced friction, the air is thrown out. It is also because of the earth's rotational motion, and hence the air is thrown out. Due to this, the amount of air is low, which leads to the development of a low pressure belt. This condition is observed in the area between 55° and 65° parallels in north as well as south pole or hemispheres. Moving on to the polar high pressure belts. In both the polar regions, the temperature is below 0°C throughout the year. Hence, the air is cold. As a result, high pressure belts get formed. These are called as polar high pressure belts. They generally occupy the area between 80° and 90° parallels in both the hemispheres. So children, in both the polar regions, that is in the north as well as in the south, the temperature is very low. It is below 0°C throughout the year. Hence, here the air is cold, due to which again the air cools down and becomes heavier and starts descending or coming down, and thus high pressure belts are formed, and these are called as polar high pressure belts. As we have seen earlier that due to earth being curved, the area decreases, and similarly here also the area occupied is 80° and 90°, which is just 10° parallel between the parallels in both the hemispheres. So here these were the pressure belts, how they are formed and their areas. Moving on to the duration and intensity of the sun rays. The duration and intensity of the sun rays varies during particular periods of the year in both the hemispheres. As a result, the location of the temperature zones and the pressure belts dependent on the sun's heat also vary. This change is of the order of 5° to 7° towards north in Uttarayan and 5° to 7° south in Dakshinayan. This is called the oscillation of pressure belts. Children, here it is told that the duration means time and intensity means strength, so which means that the time and strength of the sun rays differs during particular periods of the year in both the hemispheres. And due to this, the locations or the positions of the temperature zones as well as the pressure belts also varies or changes. Why? Because it depends on the sun's heat. This change is of the order of 5 to 7 towards north in Uttarayan and 5 to 7 towards south in Dakshinayan. And this is called as oscillation, means which moves back and forth in a regular rhythm. So these changing movements is called as the oscillation of pressure belts. Children, you need to always remember that the major difference between the temperature zones and pressure belts is that the temperature zones are continuous and are spread from the equator to the north and south poles from torrid, that is hot, to frigid, that is cold zone. But the pressure belts are not continuous and areas of high and low pressure are found in different regions from the equator to the poles. Now, let us learn about the effects of air pressure. First is origin of winds. Children, air pressure causes the beginning of winds. Also, you know Antarctica is the most windiest place on our planet Earth, and it has been recorded in the Guinness Book of World Record and National Geographic Atlas. Generation of storms. Another effect of air pressure is that it leads to the generation of storms. Storms means the strong wind that move forcefully in a specific direction, which usually leads to rain, thunder, lightning, and even snow. Convectional type of rain. Convectional type of rain is another effect of air pressure. Children, convectional rainfall occurs when the energy of sun heats the surface of the earth, causing water to evaporate to form water vapor. When the land heats up, it warms the air about it. This causes the air to expand and rise. As the air rises, it cools and condenses, and if this process continues, it leads to rainfall. And the last effect is that air pressure affects the breathing activity too. Children, for our lungs to inflate means fill in air inside, the air pressure in our lung has to be less than the air pressure outside the lungs. This is because air moves from high pressure to low pressure areas. And during bad weather and high altitudes, the air pressure is low and hence it makes us harder to breathe. The next subtopic is isobars. The line that joins the places of equal pressure on the map is called as an isobar. Observe the map given on the page number 19 and let's study the distribution of air pressure. In this figure, distribution of annual average pressure in the world is shown and the value of air pressure is shown in millibars. Always remember that air pressure is measured in units of millibars. For this, an instrument called barometer is used. You can see this in the figure 4.3. The air pressure at the Earth's surface is measured with this instrument. So we have come to the end of our lesson, air pressure. That's all about it. Stay home and stay safe. Thank you.